Welcome students to another lecture of Survey of Physical Sciences. And in this lecture, we're actually gonna discuss a little bit about weather and climate. And let's think of this class as, we talked in week number 6 that the Earth's crust is in this ongoing transformation, right? So there is tons of processes that are happening with the surface of Earth that changes the surface all the time. And in week number 7, the idea is to work with the atmosphere. So the previous chapter, I explained to you a little bit about of this atmosphere, right? And then in today's lecture, we're gonna study some of the properties that sort of, changes these at the conditions in the atmosphere. So let's try to make a parallel, such as if the Earth's crust change, so can change the atmosphere. Okay, and that's the two main things that we're trying to accomplish in these 2 weeks. So we're gonna study how Earth's atmosphere goes through these various cycles and how that creates the weather that we know and the climates in a more general sense. So let's start with a foundational idea, which is the discussion about clouds and precipitation. So you know that water follows a cycle on Earth, right? And we call that cycle the hydrological cycle, okay? So this hydrological cycle can be divided into 4 main components. Okay, so this cycle, first of all, is driven by the energy that's coming from the sun, and we can actually break down this cycle into 4 main components. The very first component, and they are illustrated here in this picture. So the very first component is the evaporation of the water from the oceans. And I am representing here the oceans because, about 97 centimeters of water evaporates from the oceans every year. But evaporation can happen from other water bodies or water sources throughout the Earth, okay? So this evaporation, takes the water from the oceans all the way to the atmosphere. And in the atmosphere, we have the water pressure, right? So this water evaporates and becomes a gas. So this is what we are representing here in number 1, is sort of this gas that we call the water pressure, okay? Then the second process is when these clouds here, this vapor of water, are transported to other locations. They can either be stationed or transported elsewhere in the atmosphere. Eventually, they will condense and precipitation will occur. Remember that the condensation here will happen when the water reaches that dew point temperature. And then once it precipitates to the land, then the water returns back to the ocean, right? So it will find, rivers and other streams, and then those rivers and streams will go back eventually to the ocean. And like I said, even though I am representing the ocean here, you can think of this cycle also happening at, smaller scales. So this cycle can happen at many other smaller subcycles when you involve rivers or lakes or other small bodies of water. Okay, but this is the general picture that sort of is driven by the energy coming from the sun. So in this process here, we have the formation of clouds. So how are clouds formed? So what is this cloud forming process? So clouds are formed when the air masses are cooled all the way to their dew point. So remember, we're lifting up this hot air, right? And then when it reaches a certain altitude in the atmosphere, that will reach the dew point, which is the point where the water starts to condensate. And I talked very briefly about that in the other class, okay? And this upward movement of the hot air is what causes the cooling of the water to the point where it starts condensating again. So it's the as that vapor water is cooled to its dew point when that mass of air is moved upwardly. Okay, so we're moving here to a region of lower temperature in the atmosphere. So remember, we're going up, and as we're going up, temperature generally decreases to a point where the water, might condensate or even freeze. All right. So this upward movement is caused by three factors. Okay. So one of them is convection, and we discussed about convection in the other class. So convection is when the air mass that is less dense raises, and then that space is occupied by a much denser air mass, and then there is this constant cycling between the hot and cool airs. Another factor that can cause the upward movement besides of the convection is the presence of barriers such as mountain ranges. So in this case, the mountain ranges will force the air to move up, literally as if the air was escalating up that mountain. And then the other factor is when those air masses, they collide due to their different densities, and those different densities are caused by different temperatures, right? And we're gonna take a look at these masses sort of colliding with each other. Always remember that if it is warmer, the air mass is less dense, and if it's colder, the air mass is more dense, it's denser. Okay, so these three factors will move the water vapor or the air all the way up, and then at some point the air starts getting cooler and cooler to a point where it condensates and then it precipitates. So generally that's the idea, but the cloud forming process also depends on the atmospheric stability. Okay, and before I move on to talk about the two types of atmospheric stability, I want to make sure that you understand that this air mass that's moving up, we're going to call parcel. Okay, so it's a portion of air that's moving up. And when this parcel of warm air is pushed up, it expands and becomes cooler. Okay? What will happen to that parcel when it reaches a certain point in the atmosphere will depend on the density of that parcel and the temperature of the surrounding air. Those two things in combination. Those two things in combination now will create this atmospheric condition that can either be a stable atmosphere or unstable atmosphere. So these two graphs, one refers to the stable atmosphere and the other one refers to the unstable atmosphere, is telling us what happened to this air mass that we're calling parcel of air when it is in a stable atmosphere or in a unstable atmosphere. In a stable atmosphere, what's going to happen is that this lifted parcel of air is cooler, and because it is cooler, this parcel of air is denser than the surrounding air. So this line is representing the parcel of air, and this line is representing the temperature of the surrounding air. As you can see, if you move to the right, this temperature increases. So here the parcel that's lifted up is cooler than the surrounding air, therefore denser than the surrounding air. And because of that, the lifted parcel will return to its original level, sort of sinking back when this upward force that's moving the parcel up is removed. Okay? Here we're gonna have the formation, especially of the clouds, of the stratus type of clouds, which we discussed also in our last class. Okay? The other condition is the unstable atmosphere. So the unstable atmosphere, which is represented here by this graph, is when a lifted parcel of air is warmer, and because it is warmer, is less dense than the surrounding air. As you can see here, we have the parcel of air which is warmer than the temperature of the surrounding air. And because it is warmer, it's also less dense. What happens with a less dense parcel of air is that it keeps moving up. Because of that, because the fact that the parcel is warmer and less dense, the parcel then is moved to a higher level in the atmosphere, to a higher altitude. So that's why the arrow is pointing up, because it's moving that parcel up. And it will continue to rise even after that uplifting force is removed. Okay? Here, usually we're going to have the formation of cumulus clouds. Again, here we're going to have the formation of stratus clouds. The air that moves up, sooner or later, either for those two conditions, because this air also was eventually being lifted up and then it starts sort of sinking back. So in both conditions here, sooner or later, the dew point of that parcel of water, of the parcel of air, is reached, and that air will become saturated, and the condensation nuclei will start to form, and then eventually that will lead to rain. Okay? So again, we've got two types of atmosphere. One is stable, meaning that the parcel of air is cooler and denser than the surrounding air, and an unstable atmosphere when the parcel of air is generally warmer, less dense than the surrounding air. Eventually, these parcels of air, they will move to a certain altitude where the dew point is reached, saturating the air, forming the condensation nuclei, and that will lead to the rain. Okay, which is sort of described in this slide here. So this slide is just a summary of what I just explained. So you have this rising moist air that's cooler, eventually reaching the dew point temperature, which is when the condensation starts. Here then you have the condensation nuclei forming in that saturated air. And then eventually here you have the droplets of the air, of the vapor, of the water vapor appearing as clouds when condensation actually occurs. Eventually, like I said, precipitation also happens. So precipitation is actually the return of this water back to the Earth's surface, okay? Two main things, the dew and the frost here, they are not precipitations, they are just surface processes. Remember, the dew is from that glass example I gave you, when the glass of water starts sweating, right, which is the condensation of the water in that surface. That's not precipitation. We just call dew. Okay, precipitation can happen in two ways. So you have the coalescence process and also the growth of ice crystal that we're gonna call the ice crystal process. Okay, so in the coalescence process, this process will take place in warm cumulus clouds that are near to the oceans, especially in the tropics. So here in the coalescence process, you have large cloud droplets that will collide with each other, and in this process of collision, they merge together with smaller droplets as they fall. So coalescence means they are coming together, okay? Remember of that. Because it's happening close to the ocean, this coalescence process, the clouds here will have their condensation nuclei filled with some salt. The second process is the ice crystal process. The ice crystal process, which as the name suggests is when there is the growth of the ice crystals, is when it usually takes place in clouds located at middle latitudes. So this will occur near to the tropics. So this will occur near to the middle latitudes. And here, this ice crystal process happens in clouds that are extended high enough into the atmosphere where the water reaches the freezing point. So it's very high in altitude. Then after that water reaches the freezing point, the ice crystals, they start to form and they capture the other nearby water of molecules of water, and then they grow to a larger size. Okay, and as they grow larger, they might also coalesce with other ice crystals that are being formed nearby or other droplets of water, and they will soon form clouds, and then they soon also precipitate. Okay, here we usually have this usually happens. Sorry, I got some brain. My brain is processing faster than I can speak. I'm sorry. So here, this usually happens as a snow during the winter, but also during the summer if that water reaches these high altitudes in the atmosphere. Because it's summer, that water actually can melt when it's falling down and will fall as rain during the summer. Okay, so precipitation can happen through those two processes. Here is when the water form those large droplets that they coalesce together and eventually they fall. Or here when the water reaches a very high altitude to a point where it freezes and then it falls back. Okay, it is as simple as that. There is also another type of rain, of precipitation, which is when acid rain happens, okay? And I don't have a specific slide about acid rain, but I do have a video that I want to share with you, okay? And I'm gonna stop right now to put the video in and then let you guys watch the video to understand a little bit more of how acid rains are formed. Oh, before I go, usually we can tell sort of of the weather by the cloud that we are gonna observe in the sky. So if we look in the sky and we observe some sort of cumulus clouds, those will produce usually showers and thunderstorms, but only for a brief period. And then the stratus clouds will cause longer periods of drizzle or snow. Drizzle especially in the summer, snow especially in the winter, okay? The type cirrus doesn't produce precipitation, okay? I brought this because, you know, usually cumulus are formed by these the coalescence process, and stratus are gonna be formed by ice crystal processes. Okay, so let me introduce the acid rain video, and then we're gonna keep talking about the weather now.
Normal rain is somewhat acidic, having a pH of about 5.6. This acidity results from carbon dioxide in the atmosphere reacting with water vapor to produce carbonic acid. Acid rain has a pH below 5.6. It results from sulfur dioxide gas and gases of nitrogen oxides reacting with water vapor to form sulfuric acid and nitric acid respectively. Sulfur dioxide is the product of combustion of coal. Nitrogen oxides are the products of combustion of gasoline. Acid rain can seriously affect some lakes, especially in the spring when a pulse of acid enters the lake with melting snow. Lakes have buffering systems that keep the pH of the water near 7 or above, but over a number of years, acid rain can deplete the buffering capacity of the lake, causing the water to become acidic. Lake organisms vary in their sensitivity to acid waters. Often, it is the larval stages of fish and insects that are the most vulnerable. As the acidity of the lake increases, the most sensitive fish species disappear first, such as trout and bass, followed by less sensitive species, such as northern pike.
All right, let's continue this class talking about the factors that will produce the weather, okay? When we discussed about the planet, the Earth planet, we and the movements, right, and the motions that Earth can execute or executes, we got to the conclusion that seasons are determined, right, by this motion that the Earth does around the sun and also around its own axis. What I'm gonna talk about here is two other events that can cause weather as well, and they are the air masses and the weather fronts, okay? There is also another weather producer event, if we can call it that way, which is high and low pressure patterns, but I'm not going to specifically talk about them because they are actually associated with the fronts and the air masses, okay? So let's recapitulate what I discussed last chapter when I showed you that globe with the convection cells, and I told you that there are 6 convection cells, and that generally drives the rain or dryness in some regions, right? So that is sort of summarized here as this idealized model, okay, which we sort of see happening for the whole globe, but local, I don't want to say local weather, but like local changes can occur, and there are local factors. I think that's a better way of putting it. There are local factors that will drive the weather in those regions. So generally, what we discussed with the model is that those regions that are, 10 degrees north or 10 degrees south of the equator will receive more direct solar energy. And we said that this solar energy in those regions closer to the equator, the air in those regions will heat up, and as it heats up, it expands and becomes less dense. Because it's becoming less dense, the air will rise, okay? And as the air rises, it starts spreading towards the poles, north and south, okay? As the air rises, the air starts cooling and becoming less denser, and becoming denser or more dense. As the air becomes denser, it will sink back to the surface at around those latitudes of 30 degrees north and 30 degrees south. Okay, that's the convective cell I explained in the previous class. Okay, so here I also want to add that part of the air goes back to the equator, and you saw that in the video, goes back into the equator, completing a large convective cell. Okay, but the end result of this sort of a cycling of the circling, let's put as a circle because it's a convective cell. The end result of these factors is that we're gonna have a belt or band of low pressure around the equator, and that low pressure is because the warm air is rising, and then we are gonna have bands or belts of higher pressure around the 30 degrees north and 30 degrees south of the equator. And that's because of the falling air that's sinking back in that region, the air that's cooler and denser. Okay, so the remaining portion of the air will move back to the equator, completing the convective cell, and portion of the air will keep moving towards the poles around that 60 degrees north and 60 degrees south, forming another belt around that region. Okay, so you're gonna have those connective cells forming those belts of low and higher pressure throughout the globe. All right, however, that it's the sort of a general picture. Okay, but the weather itself, it's not only influenced by these by the amount of light in the equator region that drives those cells, but also by two other processes, or three, right? That here we're gonna call the air masses and the weather fronts. Okay, so I have 3 slides now that I want to discuss first about the air masses, and then about the weather fronts. Okay, we're not going to discuss about the third factor, which is the high and low pressure systems, because that's sort of a mix between those two. And you also got the main idea when we talked about this idealized model. Okay, so let's move on to the air masses. So an air mass can be defined as a large horizontally uniform bodies of air. Okay, so they form when a large body of air remains over a large area of either land or water, and that water mostly ocean, okay, for an extended period of time. So here you can see some of these masses of air that are formed either over the continent or over the oceans, okay? So that large body of air we call air masses, okay? Those air masses, they look like the land or the ocean beneath them. So the this air mass here will have features and characteristics that will be similar to the land where it sits, that sits beneath it. So this one specifically here will be cold and dry, for instance. This one would be warm and moist, depending on the regions where they sit. But those air masses, they can move. And we're going to talk about this in the next slide, okay? So, within the same air masses, usually the moisture and temperature conditions are nearly the same. So the whole air mass that you are looking at here, has similar moisture and temperature, and that applies to other air masses too. And we have four main types of air masses. Air masses are classified according to their moisture and to their temperature conditions, okay? According to their temperature conditions, they can be either tropical or polar. Polar is when those air masses are colder, so they are formed by regions that are cold, such as the polar Antarctic regions. And tropical air masses are air masses that are formed in warm regions. Besides of being classified according to their temperature, they can also be classified according to their moisture, okay? And according to their moisture, they can be continental or maritime. So continental means that they are dry because they form over land, and maritime means that they are more humid because they are formed over bodies of waters, specifically the oceans. So you can have four types with these two combinations, right? So you can have the continental polar, which is the one that's formed in the land. That means that it's dry and cold. You have the maritime polar, which is moist and cold. You have the continental tropical, which is dry and warm, and the maritime tropical, that is moist and warm. Okay, and you can see some of these air masses represented in this picture here. So for instance, you have the continental polar air mass, which would be continental mean that is dry, polar means that is cold, okay? And you have here the maritime tropical that comes from the Gulf of Mexico, that is tropical, that means that is warm, and maritime means that is humid, okay? They dictate the weather, sort of, okay, in combination with the weather fronts. So let's talk about the weather fronts, and then I want to come back to this slide to explain what we observe during the 4 seasons. And let's try to put all those ideas together. So weather fronts can be defined as the boundaries between the air masses at different temperatures. So for instance, the boundary between this air mass and this air mass creates a front, a weather front between those two masses, okay? So the weather front is actually a thin transition zone between two air masses, and that is where the weather will occur, okay? So when those two fronts, they sort of collide with each other, when those two masses collide with each other and form those fronts, then we have weathering occurring right there, okay? Generally, over or beneath that the air mass, the weather will be sort of stable. But in the weather fronts, that's when we're gonna have rain or dry seasons or cold seasons or hot seasons, all right? Or hot weathers. I think I should not use the term seasons in this specific case, okay? So here we have two types of weather fronts. We have the cold front and the warm front. We also have the stationary front, and I think there is another one called the occlusive fronts, but we're not gonna give a lot of attention to those other two, especially the occlusive ones, because the cold and the warm fronts are more visible and observable for the context that we want here. So the cold front type of weather front is formed when the cold air mass moves into warmer air and displaces that warmer air upwardly. So here you have a cold mass moving to the right, and here you would have a warm air mass, okay? When this cold air moves towards this warmer air mass, the boundary between those two fronts the boundary between those two masses would be a front. In the case of the cold front, the cold air is moving and displacing that warm air upwardly, okay? I think I have this other representation that sort of helps us visualizing this a little bit better. So here you have the warm air that's being pushed up, moved up as the cold air advances, okay? If the warm air is moist, then the moist air that moist air rises and it's cooled down to the dew point, leading to the accumulation of condensation nuclei, forming cumulus types of clouds, okay? Which can lead then to thunderstorms, for instance, okay? So here in this example, that's what you are actually observing. So the cold air mass is sort of like a bubble of cold air that's moving into the land and displacing, the warm air upward, okay? The opposite sort of happens with the warm front. In the warm front occurs when the warm air mass advances over a cooler air mass, okay? And in the process of moving over a cooler air mass, you form sort of a long and gently sloping front. So it's not as bubbly like as the cold front, okay? It's more of a slope. It's more of a like a more diagonal slope and less rounded slope here. Okay. Here we're gonna have the formation especially of cirrus and stratus types of clouds, and clouds here may form in advance of that front, and as a result of these clouds you can have drizzle. You can also have the occurrence of fog, for instance, and here you have light rain continuously for long periods. Those rains can last for days. Okay, here the rains will last for a brief period compared to the warm fronts. Okay, again, front is where one air mass finds the other. When the cold air mass finds the warm air, that forms the cold front. When the warm air mass finds the cold air mass, that forms the warm front. Okay, and that is coming from these big masses that I showed you in this map. Okay, it's either the cold moving towards the warmer, or the warmer moving towards the cold. Many factors can influence which one is moving to which direction. Okay. Then we also have the stationary front. We also have a fourth type, but let's just focus on the stationary front here, which happens when the forces influencing the warm and cold air masses, they sort of become balanced, meaning that the front stops advancing and then they recede. I think we can put that way. They recede. They sort of go back. Okay, so the stationary, as the name suggests, happens when the boundary of that front is not advancing on top of each other. Okay, so here I have these two fronts sort of represented. So here you have the cold front, and then here you have the warm front. The cold front is when the cold air moves and displaces the warm air upwardly, and then in this process, that air, if the air is moist, the air will go up, and as it goes up, it cools back down, and then this leads to the accumulation of clouds, and then it eventually rains. Okay, here in the warm front you have the cold air here, but then you have the warm air mass advancing over the cooler air mass, forming this more long slope. Okay, less bubbly like, less circle like, and more straight like type of slope. All right, so here the clouds will form in advance of the front, so the front is right here and the clouds can form in advance there, but some clouds can also form at the very front, and then that's when we have drizzles, fogs, and the rain here can last for days. Okay, so again, we have air masses that are large body of air that's relatively uniform and uniform in temperature and humidity. It will form over regions with a consistent conditions, such as the land or the oceans, and as it moves, it will bring its characteristics from that region. So those characteristics can be tropical or polar depending on the temperature. If it's tropical when it's warm and polar when it's cold, and can also bring, a dry or humid type of air, if it's a maritime for humid and continental for dry. So we're going to have the maritime are formed over bodies of water, specifically oceans, and continentals are usually dry because they are formed over land. So here in this example, you are observing the maritime tropical, which is warm and humid, and also you are observing a continental polar that's forming on top of Canada and northmost regions of the US, which means that this one is cold and dry, okay? As for the weather fronts, a front is the boundary between two different air masses, okay? So here you have a cold air mass and a warm air mass, and you have the boundary between them, and that's what we call front, okay? So when those air masses they meet, they usually don't mix very easily because they are different in temperature and density. So instead of mixing, there is a front, okay? That's when they collide. And then in those fronts, we're gonna have the active weather. Usually at the air masses, the weather is more stable for longer periods, but at the very front, the weather is more active, okay? So we have a few types of fronts. Here you have the cold front. The cold front will happen when the cold air mass pushes into the warmer air mass. So here the dense colder air goes underneath the warmer air and pushes the warmer air upwardly. The weather that is formed at this front is usually a sudden drop in temperature. You also have the occurrence of thunderstorms, right, represented here, and heavy rain. But then once the front passes, you have clear skies and colder temperature, because then the cold air takes over that space. You also have the warm front. The warm front is when you have the warmer air mass sliding over, right, advancing over the cold air mass, and the warm air gradually here will rise over the cold air, and the weather that we have at this type of front here is usually a more steady weather, sort of, but you can also have light rain that lasts for longer periods, or snow depending on the temperature, and then eventually here you have warmer temperature, okay, because then the warmer air mass sort of takes over. And the last type is the stationary, which is when neither of those masses they move towards each other, okay? Now you can ask me why this matters. Why am I learning about this? Well, the fronts, like I said, is where the active weather will happen. So the interaction between the cold and warm air masses, they can cause clouds, they can cause precipitation, and also more aggressive types of rains like storms or thunderstorms, okay? So people use this to sort of predict changes in the weather. And you probably, if you watch television, which this generation might not watch as much, but if you watch the Weather Channel, they will always talk about the weather fronts and the masses and the air masses, and how that would change the weather over, the next few days, sort of thing, okay? I do want to go back to this, not this one, this one. I want to go back to this to give you a more solid example, and kind of combines these this understanding with the seasons. Okay, so one example here that we can associate with is, imagine for instance this continental polar mass, which is a cold and dry air mass that's coming from Canada, and it's moving south. Okay, as it moves south, it meets a warm and moist air air mass that's coming from the Gulf of Mexico. All right, so this is what we call the maritime tropical air mass. What happens when they find each other is that this one, the continental polar, forces the maritime tropical upward very quickly, and the result here, because this is a cold front, the result will be a thunderstorms and even tornadoes along the cold front. Okay, then another example here, let's look at this one coming from the Atlantic Ocean, and this one also coming from the continent from Canada. So here let's say that you have this warm, moist air coming from the maritime tropical, from the Atlantic Ocean. Then it's moving north, okay, northeastern the USA. Then there is the cold, drier air mass coming from the Canada, and this one is sitting over here in this place. Because this warm air is lighter, what happens then, it's the warm air will rise slowly over the cold, dense air mass that's already in this region. You see that this one is moving here, so that's finding this one. But this one is moving up, which is finding the stationary, this stationed air mass right here. So because this one is warmer and lighter, it rises over the cold in that region. Okay, so this will lead to forming layers of clouds. So that's when we have the stratus. This will cause most cumulus, and this will cause mostly stratus types of clouds. And as the warm air mass approaches the area, we'll experience light rain or even snow, depending on the temperatures of that season, that can last for hours or even days. Here you have the thunderstorms happening for a brief period of time. But after the front passes, you have a clear sky, but the temperature is higher and usually the conditions are more humid. Okay, how can we associate these with the seasons, right? You might be asking, but Carlos, what? I can't make sense of what you were talking about. Okay, so during the spring, what's usually happening? And of course, this is usually, okay, because everything can change. Maybe 2 years from now, I'm gonna be changing the way I'm explaining these air masses, okay? But so far, let's stick with what we know that usually happens during the spring, summer, fall, and then winter. So during the spring, we have a warm, humid air coming from the Gulf of Mexico, meeting the dry and cold air from Canada. So here you have mostly cold fronts, but you can also have some warm fronts being formed in this during this season. So usually the type of weather we're gonna observe during the spring is gonna be, thunderstorms, and depending on the region, especially in that tornado alley, you're gonna have lots of thunderstorms and tornadoes and very strong winds because you have these fronts colliding with each other. But then what happens is that the warm front sort of takes over, and then summer approaches, okay? Then during the summer, what you are gonna have is that this warm and humid maritime tropical air mass from the Gulf of Mexico dominating much of the country, especially around our eastern region, okay, in the eastern coast. I do think there are some students that are located all the other way of the US, and some are even outside of the US at this moment. But here in the US, what we are going to observe here is that in the summer now, the this air mass already took over. So in the western portion, you're going to have a more of a stationary front. Sometimes cold fronts can invade this region, and that's when you have those sparse rains. But mostly the weather here is going to be hot and very humid. And if you live around this coast, if you are in North Carolina, Virginia, for instance, you can suffer with this humidity. And that's because of the warm and moist air mass that's coming from the Gulf of Mexico, okay? All right, so how about the fall? What happens next is fall, right? So here in the fall, you're gonna have mostly of the continental polar mass pushing the warm mass again. And you know, what's driving the occurrence of those masses again is the amount of solar energy we're getting, and that's either, you know, being way too much, that's cooling that's evaporating the oceans, or not too much, and then, you know, you're dropping the temperatures. I think you guys can associate now the amount of light with you know, cooling or warming the air in those regions. But anyways, so in the fall, you're gonna have the more cooler continental polar air mass sort of pushing back into the south of the states, and, you know, especially the US, which is the case that we're talking here. Most of the fronts that we're gonna observe will be cold fronts now, and the weather will be usually cooler and drier because of this air mass taking over the entire country, okay? You can also have some thunderstorms in that during that period, but you know, mostly you're gonna have a sort of a transition between the continental and maritime tropical, okay? And that's sort of what happens in the spring as well, right? So that's why they are transitional seasons, where you have those air masses colliding with each other and causing this weather that is not stable until that actual air mass takes over and the weather becomes more or less stable, right? Then you have the winter, which is when, you know, the dominant now will be the continental polar air mass, and also we've got some influences from the Arctic air masses as well, which is also cold and dry all over the US. Here you're gonna have mostly cold fronts. Sometimes warm fronts can also happen, okay? And there is another type of front which I did not talk about, but it's known as the occluded fronts that can also be formed. The weather pattern here is gonna be snowstorms or even blizzards, especially in the north and Midwest around Indiana, Chicago, right? You can have some ice storms around our area, which is, you know, we're not as cold as the north, so that's why that storm will fall, and then you can observe the ice forming on the road. But here, what's driving here is because now the air mass is sort of settled across the continent. Okay, but some warm air masses can also come up and then cause some snowstorm conditions. Okay, so again, during the spring, you have mostly warm front meeting with cold and dry front, and then you have this transition between them two. It's a very unstable type of weather because there is a front of those two airs. But during the summer, one air mass takes over the entire country, or mostly the entire country. Then during the fall, those masses, they collide again because now the northern hemisphere is cooling back down, and then during the winter this mass advances and then takes over the entire continent again. Okay, Carlos, does that happen around the equator? Yes. So around the equator, you're gonna have some of these masses also being formed. Again, I'm gonna talk about the pattern in Brazil. Okay, so in Brazil, for instance, or even around, if you share with Brazil a lot of the Amazon rainforest, we know that a lot of that evaporation that happens from the Amazon rainforest is driven south of the Latin America, and then it's gonna rain there. So for instance, regions as like my region, like São Paulo region, will receive a lot of storms coming from the rainforest, but there are some air masses that can also come from the ocean and invade the entire Latin American continent, okay, and then cause some weather instability as well. All right, so of course we're in the U.S. and taking the U.S. as an example, but these air masses also exist throughout the globe, and it's very much influenced by what's beneath those air masses. Okay, now we're gonna talk about some cyclones, some storms, thunderstorms, and then so on as we advance about learning about the weather. But before we move on, I do want to make a pause here to show you another video that sorts of summarizes this idea of the weather fronts. Okay,
in the animation, a warm front forms when warm air moves toward cooler air. The warm air is pushed higher like a wedge. As the air rises, it cools and water droplets may condense. If the temperature difference is large enough or the air is moving fast enough, precipitation from a nimbostratus cloud may result. In the second sequence, a cold front forms when cold air moves toward a warmer air mass. The cooler air tends to stay close to the ground as it moves forward and acts like a wedge. Cumulonimbus clouds or thunder clouds are associated with cold fronts. The anvil shape of the cloud results from the warm air being pushed by the underlying cold air into a higher, cooler layer of the atmosphere.
All right, now that we finished taking a look at those air masses and weather fronts, let's keep going. Now I want to discuss about cyclones and also thunderstorms, tornadoes, and hurricanes after we move on to climate. Okay, so in this slide I just want to spend a brief moment talking about a cyclone. So the cyclone is actually a large scale weather system that's centered around this low pressure area where the air will actually spiral inward and upward. Inward, sort of entering towards the center of the cyclone, and upward, moving up, as you can imagine. Okay, so the cyclones are usually associated with clouds, winds, and also precipitation. and they are formed in both tropical and mid-latitude regions. So tropical between the tropics, all right? So what are the step-by-step processes that form a cyclone? So the very first process that we can say is when there is a low pressure center forming in the area. So a low pressure center forms, and I do have some pictures sort of illustrating that, but let's try to imagine that a low pressure system will form, and here I am representing that by L, will form when a warm air at the surface rises. Okay, we discussed about that millions of times already. So when that air that's warm moves upward, then leaves behind this low pressure system. Okay, so as this warm air rises, it reduces the atmospheric pressure at the surface right below where it rose from. So this rising air creates a certain of a vacuum effect that pulls, that draws in the air from the surrounding, okay? And the air from the surrounding is a higher pressure air, essentially, okay? So you have this rising air creating this vacuum effect, drawing, pulling into the cyclone the air from the surrounding higher pressure areas, we can call that way. So then the second step is when the air moves towards the low. So the low pressure system. So in response to the pressure difference, the air from this surrounding high pressure areas, they will move toward the low pressure center, okay? But because of the Earth's rotation, the air doesn't flow in a straight line, okay? The air actually spirals. And that's what we call the Coriolis effect, okay? So in the northern hemisphere, the air will spiral counterclockwise. And then in the southern hemisphere, the air will spiral clockwise, okay? So as the air is moving towards the low pressure center, this air doesn't move in a straight line, it's a spiral, and then it spirals either counterclockwise if you are in the north hemisphere, or clockwise in the southern hemisphere. Then as the air converges at the center of the low pressure system, it is forced upward because there is, this high pressure system coming below it and pushing the air up. Also due to the convection process that we already discussed. So this rising air will cool down, and if the air contains moisture, then clouds will form, which will lead then to the occurrence of rain, storms, or even snow, and that will depend on the temperature of that region. And that's how essentially a cyclone is born, okay? So a cyclone, you have this rotating, rising air system with clouds and precipitation, okay? That's what we call a cyclone. Essentially, the warmer and moister or more moist the air available is, then the stronger the cyclone will become. So if you are in a region where the air is warmer and moister, then the stronger the cyclone will be. Then now the three types of storms. We have the thunderstorms, tornadoes, and hurricanes. They are all categorized as a rapid violent weather change, and it's often associated with the passage of a either cold or warm front. Let's take a look at the thunderstorm, okay? So here, the thunderstorm can be defined as a brief but very intense storm. And by brief, I mean it lasts for about a few hours, not really days, okay? If it evolves to days, that is not a thunderstorm. Then, it's essentially a rain or some other sort of precipitation. We also discussed about what kind of cloud will lead to that effect, okay? So this brief but intense storm usually is followed by rain and lightning and thunder, okay? There is also gust winds, which are those winds that are very, very fast. And sometimes thunderstorms can also be followed by hail, which is essentially a big block of ice that falls from the sky. Okay. Usually thunderstorms, they will develop in warm and very moist and unstable air with something moving that parcel of air upward. And we already discussed about the factors that can move that parcel of air upward. It can be convection, it can be a mountain range, for instance. Okay. In the northern hemisphere, because that's where the class is taking place, usually thunderstorms will occur around July. That's when we observe most of the thunderstorms happening. And the life of a thunderstorms, if I can call that, can have generally 3 stages, okay? And they will last for a few hours. The very first stage is the cumulus stage. So this stage happens when the warm and moist air is lifted, and that air movement is only upward, as you can see in my figure A here in this graph. So this is the cumulus stage, and then here you have the air mass moving upward only, and the air mass expands as it goes up because it's warmer, but then also as it goes up, it starts to cool down to its dew point, which is the point where it condensates, okay? And then here we're gonna have the formation of the cumulus clouds, and not only they form, but they also growth, as you can see how they are evolving to scenario B, which is the mature scenario. So the mature scenario is actually when precipitation begins and precipitation reaches the Earth's surface. Okay, so during the stage B, the saturated air, now that reached the dew point, reaches freezing level in the atmosphere, and then ice crystals and also snowflakes can form through that ice crystal form process that we already discussed. And if they are too large, that snowflake or that ice crystal, they will fall, okay? And depending on the temperature that you are, some of that falling frozen water can melt and become rain, like water in its liquid state. That's literally what I meant here. Or they can form hail, again, depending on the temperature where it is occurring. So that's stage B, where you have, the water falling back, the water precipitating either in its liquid stage or ice as well. But during B, because it's a mature stage, you can also still have some of this cumulus sort of piling up. Okay, so during the mature stage, you can still have some convection of the air, bringing this warm and moist air up, but at the same time you can have the air going down. This process of going up we call updrafts, and the process of going down we call downdrafts, okay? And then the very last stage, which is C, as you can see here, is the dissipating stage, which is when the thunderstorm usually is going to an end, okay? This is when the updrafts are exhausted, so you no longer have the warm air going up, okay? And then you only have the air going back down and the water going back down. So thunderstorms are usually formed in a cold front, okay? The cold front is when the cold air mass comes in, pushes the warm air upward, okay? And then at the very front, you have the occurrence of thunderstorms. In the thunderstorms, we can have the occurrence of lightning and thunder. Essentially how they are formed: lightning, as you can imagine, is the light that you see in the sky during a thunderstorm, and the thunder is the sound that you hear coming from the sky during the thunderstorm, okay? So the very first thing that happens is that, you know, this updrafts and downdrafts of air moving up and down separates the electrical charges. And then these charges, they will eventually accumulate in different parts of, I don't know why it's thunderhead here, but it should be the thunder cloud, which is this thing that you were looking at. So, you know, as the air moves in, moves up and then down, you have the separation of the electrical charges, and those charges are accumulated at different parts of the thunder cloud, okay? Usually the upper parts of the thunder clouds, they tend to accumulate positive charges, whereas the middle and mostly the middle of the thunder clouds, they tend to accumulate more negative, because the bottommost part of the thunder clouds, they tend to accumulate both positives and negatives. Okay, so we call these areas the centers of electric charge. Okay, and then what happens is that when the voltage of these centers is high enough and overcome the insulating properties of the air, right? Because the air is a very good insulating material, then a giant electrical discharge will occur. Okay, and then, you know, you have a difference in the potential between these two areas, and that creates electrical current to move along this voltage, to move along this potential difference between the charges. Okay, that's essentially, you know, moving electric charges from one end to the other in a circuit that we studied when we studied about electricity. Then we have the tornadoes. The tornadoes, they can be classified as the smallest but very violent weather disturbance, okay? They occur when there are intense thunderstorms, and they are usually categorized as a rapidly moving spiral whirling column of air, okay? So it's a long and narrow funnel shape like that these tornadoes have. The diameter of a tornado can be from 100 to 400 meters, so it can take a few hours for a tornado cross through long distances. The wind speed can reach up to 480 kilometers per hour, so the winds can be really fast. And because they are so violent, they produce a lot of damage, and the damage is usually due to the high winds, due to the drop in pressure at the center of this tornado, and due to the debris that this tornado is carrying around. So they work as a projectile hitting other stuffs. Okay, and again, they are usually associated with thunderstorms. How about the hurricanes? So hurricanes, there are different types of hurricanes, but what I want you to know is that a hurricane is a very intense low pressure area with winds of about 120 kilometers per hour. Okay, a fully developed hurricane has an eye, and the eye is usually very calm, and around the eye you have this area of hurricane winds, and then the area of hurricane winds is when you have actually rain happening, and also very potent winds happening also in this area. Okay, usually they will occur over the Atlantic and also the Pacific Ocean, east of the international date line, and sometimes we can have a typhoon, which is when that hurricane usually occurs over the north of Pacific Ocean and at the west of the international date line. Okay, so this is essentially, showing you the distance. So here you have the distance in kilometers, and then here you have the altitude also in kilometers that this hurricane can reach. So it's essentially the size of the hurricane. Okay, so clouds can reach up to 12 kilometers of altitude and about 20 to 40 kilometers of distance, okay, in this updraft turbulence area. Okay, the distance here of the hurricane eye is about also 20 kilometers of diameter of radius, and then a total of 40 kilometers of diameters. Okay, winds can range between, again, 20 to 40 kilometers, the area where those winds occur, but their speed can be of about 120 kilometers per hour. All right, so weather can be sort of predicted, and the way we predict the weather is based on mathematical models of the atmosphere, is trying to sort of predict where those air masses are going to move to or towards, and then where those weather fronts will be formed. So that's essentially what those mathematical models are trying to predict, how those masses are moving and where the weather fronts are forming. However, as you can imagine, the weather is very unpredictable, so we can't actually with confidence say what's going to happen within more than 3 days in advance. So things can really change, and that's just because we still are developing technology to understand the planet in general. Okay, we do know how to predict some of the events very good, but we are still learning about how to do that, essentially. So weather, and we're now moving into the climate. So weather is how we weather is the description of rapid change in the atmospheric conditions. That's how we can define weather. So weather changes daily, essentially, but climate will describe a general condition that will occur over a region for years. Okay, so the weather changes day by day, essentially, but the climate is usually stable for a very long period of time. All right, So climate, let's move on. So climate, is this larger weather pattern that occurs over several years. There are different factors that determine, the climate can be is important for determining different processes that happened on Earth. For instance, the type of plants and animals that will be found at a given region and location. As you can imagine, the types of forests that we have here in the US are very different from the types of vegetation that we have at the poles and that we have at the equator regions. Okay. Also, it determines, what kind of houses should be built and what lifestyles you're gonna have. Okay, if you're like me that came from Latin America, like Brazil, you're probably not used to these seasons in the US. I usually had a day that was very 12 daylights and 12 hours of daylight, 12 hours of nightlife. But now in the summer you have about more than 12 hours that the sun is up, which, I love being sun and it's like 9 p.m., but still you have to adapt your lifestyle to these changes. The climate also influences the shape of the landscape, the type of soil that's present in that region, and with the type of soil and the landscape, that will also determine what type of agricultural activity will be found in that region, essentially. Okay, so climate is very influenced by the latitude in our Earth. Okay, and that's because of the amount of energy that each portion of Earth will receive. Generally, we can divide the Earth into 3 main regions. Okay, and they will be the regions of low latitude. So in the regions of low latitudes, which are closer to the equator, you have higher levels of solar energy. So here there is a small variation in the climate over the years. So the climate throughout the year is essentially similar. I usually tell my friends that in Brazil you have hot and hotter. So we don't actually have 4 seasons well established as you have in the northern hemisphere. Okay, so temperatures are usually uniformly high in these areas. We do have, I'm just kidding, I'm just exaggerating here, but we do have in this equator area, in some areas, of course, at least summer and winter. Okay, but we generally don't observe the transitional seasons like spring and fall in these lower latitude areas. In the middle latitude areas, that's the region where the US is found, for instance, then we're gonna have differences in the amount of energy that we receive throughout the year. So there are gonna be times of the year that we're gonna receive more energy, and other times of the year that we're going to receive less energy from the sun. And that is the same for the northern portion around the Tropic of Cancer, and the southern portion around the Tropic of Capricorn as well. Okay, and then we have regions of high latitudes, and that works for the North and also South Pole. So what happens here, this region is above the Arctic circle, and also in the south, like I said. So here you definitely have one period of the year that you only receive solar a lot of solar energy, and it's day for almost 24 hours, if not 24 hours, depending on the latitude that you are. And then there's gonna be times of the year that you only see night, so you receive less amount of energy. Okay, so as you can see, we have some climate zones that are determined by these differences in the amount of energy, solar energy that we receive in these latitudes. So in general, because of these 3 low, middle, high latitudes, we can also define essentially 3 climate zones. And I mean, even though we're defining 3 climate zones, there are smaller local patterns. Okay, so this is not set in stone, so these things can change, but essentially we divide these zones as a tropical climate zone, which is near the equator because it receives most or more solar radiation, and the temperatures here are essentially higher, okay, with very small variation throughout the year. Then we have the temperate climate zone, which is where, again, we are found, where the US is found, most of the Europe as well, Russia as well. And then, in the south, this is where Chile, for instance, is found, Australia is found. Here, temperate means that it's an intermediate zone in between the other two, okay? So patterns here will change throughout the year. So again, you have months of the year where you're going to receive more solar energy, and months of the year you're going to receive less solar energy, okay? And then the other extreme is the polar climate zone, again happening at the south and the north. So here you're going to receive the least amount of radiation, so it's essentially colder throughout the year. But then again, there are gonna be seasons, for instance, in the summer, where these regions, now the north is gonna receive most, will be a day most of the day. We receive daylight most of the day, so it's gonna be day 24/7 here, whereas here's gonna be night 24/7. And then during the winter here, this is gonna be day 24/7, and then dark 24/7 over here, okay? So it's flipped for the north and the south poles. All right, so tropical, temperate, and polar climate zones. Okay, so there are different factors influencing the climate. Altitude is one of them, because depending on the altitude, you're going to receive and emit more or less energy coming from the sun. Mountains also influence the type of weather that you get. Sometimes mountain can block the air masses from coming through. Sometimes the mountains, they can, if you live in a higher altitude, it's usually will be cooler because you're closer to the atmosphere, and you're also emitting more energy back to the space. And also the mountains change the wind pattern, right? Because it's a slope, so it changes how the wind curves through the area, okay? So I just want to bring your attention to another factor. I know that I love talking about Brazil here in this class, but Brazil has Brazil doesn't actually have a mountain, but there are some mountain-like regions over here that sorts of blocks any rain from coming to this region. So this region in Brazil, it's usually very, very dry, okay? Again, that's just another factor of how mountains can influence the wind, the climate of that region, okay? In the US, that also happens kind of similarly. You have the Rocky Mountains here that also block some of the rain formed from the Pacific Ocean to reach the states such as Arizona, Oklahoma as well, the states in the center of the US. So that's why you have areas that are drier, okay? Other factors that influence the climate can be the presence or not of large bodies of water, because that will change the how much water vapor is formed in that region and how much rain will fall in that region, okay? And also the ocean currents will also determine the regional climate in those areas, okay? The US in general can be divided into different climate zones. I'm not going to talk about each one of them because I do provide a table here where you can look through each one of them and see how different they are from each other and what is the specifics about each one of them. We here in North Carolina should be in this humid subtropical region, and that's essentially because of this Gulf, the air mass that comes from the Gulf, especially, that makes this region very humid in some months of the year, okay? But essentially we can divide the climate, and that is a thumb rule for other countries as well, as the marine climate and the continental climate. The marine climate, as you can imagine, is the climate near the ocean, so that's influenced by the air masses that are coming from the ocean, such as we have here in the region of North Carolina. And then we have the continental climate, which is found in the regions that are far away from the ocean, okay? And that's usually influenced by the air masses that are coming from large land areas, such as the continental polar air mass that's cold and dry, that moves south, okay? And then that determines the weather also in some of these regions, okay? So as you can imagine, I talked about many things that can determine the climate, okay, and the weather. So the previous class I talked about those convective cells, that they determine general climate patterns. Then here we talked about the weather, and we talked about the air masses and the weather fronts. But the overall picture is much more complicated, because not only you have those air masses and weather fronts interacting with each other, but you also have those convective cells, and also the presence of other factors such as mountains, bodies of waters, oceans or not, and the altitude of those regions, okay? So there are definitely more climate zones in these countries, and I am sure that you are familiar with the one from your own country if you lived somewhere else, okay? All right, so there are some local climates as well. So I just brought this because you probably have heard about this heat island. So usually heat island effect. So that's usually observed in large cities. And that's because large cities, they usually tend to emit more of the solar radiation because of the presence of pavement and other buildings. They will tend to absorb more of the solar energy that reaches them and emit more of the solar energy as well. So that creates some sort of a bubble that's very warm in those regions. You probably have heard about this happening in New York, I think in I can't remember if it was 2023, I think, or 2024, when it was really, really hot in New York. And that's essentially because of this, they were having these heat waves. And that's because of the heat dome or heat island effect that those buildings can have. That also happens in other large cities as well, okay? Which, of course, what happens in a large city is very different from what happens in the countryside, because, buildings and a paved street is very different from a natural vegetation, and that influences the amount of water that evaporates in the area or not. So I just thought that I would bring this information in this class. Now let's talk about climate change. So climate change is overall a natural process. Okay, we know that Earth throughout this whole life underwent through many cycles of rising and falling of its temperature. So there is some sort of expected pattern that the Earth follows based on prior conditions that we studied. So generally the Earth cooled down and warmed up many times before. So as you can see here, you had a moment where the Earth the temperature went up and then the temperature went down again, but this over the span of billions of years happened over and over. Specifically over the last 100 years, Earth has experienced 2 warming cycles. So there was a drop in the temperature, and then it rose again, and there was another drop, and then it rose again. So that's essentially what those 2 warming cycles that we experienced. But generally, in a very general term, okay, so Earth, every 100,000 of years, Earth has these interglacial warming periods before going through another ice age. So ice age has occurred many times throughout Earth's history, Earth's past. Right now, what we are experiencing is a warming period. So we are in this interglacial warming period, okay? And there is an estimation that this current interglacial warming period that we are experiencing started about 18,000 years ago. So over the next 90,000 of years, we're gonna see this temperature rising more and more until it drops down and we go through another ice age again. Okay, that is not to say that climate change is not occurring and we're not sort of boosting its effects. Okay, it's not occurring. Let me change this. So that is not to say that the climate change is not a thing that we should not worry about. Okay, it is a natural process, but we've been observing, and I'm gonna talk about this later on, that things have been we're speeding up this process of warming up of the Earth. Okay, essentially we are warming up in a natural process, but we're sort of speeding up this process. Okay, causes of global climate change. One of them, they can be astronomical factors, so factors that are beyond our control and they come from outer space, and some of them occur at the level of Earth's atmosphere. So one of the astronomical factors can be the presence of sunspots in the sun. Those sunspots, and you can see here in this figure, sunspots are dark spots that appear to move around the surface of the sun. The more sunspots the sun have, more energy to Earth, more energy reaches the Earth, which therefore increases the temperature. There isn't a good measurement for about how often those sunspots happened, but I read that overall, every 10 years, these sunspots, they appear and they change their position. But again, the more sunspots that you have, the more the temperature will warm up here on Earth. Then the other astronomical factor that we have is the changes that happen in Earth's tilt, Earth's orbital shape, and Earth's axis wobble movement, which is the precession that we discussed, I think, in week number 5. Okay, so these 3 movements, they will also they change our position, our orientation to the sun, which eventually changes the amount of energy that we receive. So yes, the wobbling, the precession is a cause of global climate change, okay? But another factor that we have here is the change in the shape of the orbit of Earth around the sun, okay? So the shape here, we defined as being an elliptical shape, okay? But this shape often in times it changes, but it changes about 2 to 5%. So it's not a big change. You cannot blame the warming that the Earth is going right now due to this, solely to this event of changing the orbit of the shape of the orbit of the Earth, okay? It is estimated that the orbit of Earth changes from elliptical to a more circular-ish of about 5% every 100,000 of years. So every 100,000 of years, the shape is less elliptical and more circular of about 5% again. And that, again, changes the amount, how we are positioned in relation to the sun, therefore changes the amount of energy that reaches the Earth. The other factor is the presence of the greenhouse gases. I, said that the greenhouse gases are important for warming up the Earth, right? Because all the solar energy that enters the Earth, part of that is absorbed, re-emitted back, and then the greenhouse gases, they will absorb and re-emit the energy back, so warming up the surface. But what we've been observing is that there is an increasing in the concentration of these greenhouse gases, okay? So essentially, again, they are important because they redistribute the heat in the atmosphere, producing this warmer climate, but their concentrations are also warring in general, okay? So 2 main greenhouse gases that we have is the CO2, the carbon dioxide, but also the CH4, which is the methane. The water vapor is also a type of greenhouse gases, okay? But the one that's changing the most is the CO2. We've been observing since the 1800s here that the concentrations of the CO2, they've been rising over the years, and the estimation here is that the CO2 that we measure today is the highest among the last 800,000 of years that has passed already. So Earth has never, in the last 800,000 of years, has never experienced this amount of CO2 as we are experiencing right now, okay? And that comes from geological data, observing old rocks and whatnot, okay? So again, those greenhouse gases, they can be water vapor, carbon dioxide, methane, and some other trace gases, but specifically the CO2 has been increasing, okay? Tropical deforestation also helps with this factor, because as you can imagine, plants, they are important to capture that CO2. So our oceans, they capture the CO2, but the more you destroy those forests, the less you are gonna be able to absorb that CO2 from the atmosphere. Okay, so it reduces our capacity of capturing CO2 from the atmosphere. And as you can imagine, there is a growing concern about the destruction of the Amazon forest that sequesters, right? So it captures a lot of CO2 that we produce, but again, oceans are way better in doing that. Okay, that doesn't mean we should destroy the Amazon forest and preserve the oceans, because both are doing their job greatly. Okay, so I know that this was about a 2-hour class. I think I had about 30 slides or so. It was a lot of information, but in general, I just want you to know about the cloud forming process. When the air is pushed upwards, and then there is a low pressure system that is left behind, which is invaded by a high pressure system. Okay, the air is pushed up by those three movements that we can say it's convection, it's the barriers such as mountains, or when two air masses they meet each other. Okay, we also talked about how the temperature of the parcel of air and the temperature of the surrounding air will create either a stable atmosphere or unstable atmosphere. We talked about the clouds are these accumulation of tiny droplets that start out, in their condensation nuclei. And I also talked about this process in the previous class. We talked about the two types of precipitation processes, right? We talked about weather, and then we talked about the air masses that we have. We have the continental and the maritime masses, and the polar and tropical. So you have continental polar, continental tropical, maritime polar, maritime tropical. Okay, but air masses in general are defined as body of air. When those body of airs they meet each other, we have the weather fronts, and then we have the cold and the warm weather fronts. I also briefly mentioned about the stationary fronts. Okay, we talked about 4 more events happening in the atmosphere that are cyclone, thunderstorm, tornado, and hurricane. And then we talked about climate in general, okay, which is this pattern observed in a larger scale than weather is. We defined that there are 3 major climate zones: tropical, temperate, and polar. But we also emphasize that there are local changes and local factors that can change the climate in specific regions, such as the altitude, presence of mountains, body of waters, and the presence of ocean currents as well. Okay, so very long class, but not really a hard class, I would say. And you guys can review this. You probably know this more than I do. Okay, all right, good luck. I'll see you in chapter number 24, which is our last chapter finally. Yay!